I decided to move the water tank under the body, regain some space inside and lower the center of gravity. Aluminum became the material of choice. As far as I know, it's not the best for drinking water, but this tank is going to be for showers, dishwashing, etc. I call it technical water. Aluminum reacts with water and chlorine that comes from city water, but in a limited way, as aluminum naturally creates a hard oxide layer. The advantage of aluminum is its lightweight, so anyway, I decided to give it a try. There are always some pros and cons. Everything started as usual with a cardboard template. Then I transferred it to SketchUp and later I sent it to a local company that creates the project for laser cutting and CNC brake press. Such a cutout is also welding ready, so this time I ended up with two halves fitting perfectly together. It saves a lot of time welding gases and materials. The bottom half is made out of 5 mm thick wall. It has a 50 mm diameter water inlet and water feed through an aluminum 16 mm diameter pipe that got a 90-degree bend. There are also two bulkheads and a water drain at the bottom. The top one is made out of 3 mm aluminum. It has 4 air vents, a water return fitting for circulation, a water level sensor, and 3 inspection hatches to clean it periodically. Speaking about inspection hatches, that was confusing. On the internet there are tens of options. They are usually cheap and must be leak-free at the same time. I decided to buy 3 types in different sizes to put my hands on them. They are all inspection hatches, but they differ in details. This one was my favorite during online shopping, but they have very partial thread with a very high pitch and they have a very thin o-ring. At some point it stops closing, so you cannot tighten it down more than that. They also did not have enough grip at the lid, so I rejected them. The white ones were the most durable and solid, I think. The o-ring was placed at the lid. They were the heaviest, they had the highest profile, and the thread had a very high pitch as well. I think they could easily withstand stepping on them. They didn't have much flexibility. Closing them felt generally very good, but they were wide, too high, and not flexible. So overall, very good quality, but not the best for my application. The last option became the most reasonable. Lightweight, just a bit flexible, with a pretty thick o-ring located at the ring. Low profile, good enough grip at the lid, and what was the most important, they had a very fine thread, which for me was the highest guarantee for being leak-free. The next problem was how to bolt this inspection hatch to the tank top. I drilled holes and I used washers with EPDM rubber, CX80 single component glue, so what you see is the complete sandwich of parts that gave me a watertight solution. I wasn't sure about that during assembly, but it worked eventually. For air vents, water feed and return, I decided to use M14 by 1.5 mm banjo bolts together with steel washers with rubber sealing. The connection requires much less torque to be watertight than standard copper washers. Alright, so this is the final merge of these two pieces. Welding aluminum is not a super easy task, and I can remember my first attempts 4 years ago. This time it went much better. The water tank came out to be leak-free from the first welding, which was very satisfying, and I understand it as my big achievement. I performed some water tests during the couple of next days. Alright, so the tank is full, there are no leaks, which is basically a huge relief. And finally, take a look at this. So this is 62 3 liters and the tank is around 15 kilograms. And when I try to lift it just from the one side, it feels really heavy. And you say like, okay, 60 liters, what's that? Not much. But this is heavy. The water tank has 7 mounts, 4 at the inner side. They all bolt to mounts that I fabricated in advance during my frame rebuild process. There are 3 mounts on the outer side that bolt to the body. These were added during the body rebuild. Inside the cabin I added a new Lilie water pump that is super quiet. Pressure is not very strong, but I will give it a try. For water purification I used a Polish product, a Duffy filter. The empty housing is around €25. I also ordered a 2-in-1 active carbon filter for €10 per piece. It also acts as a mechanical filter, so it can filter out chlorine, bacteria and essentially particles bigger than 5 microns. So that would be good enough for water that is stored in an aluminum tank. It's also black, so it fits my interior. At the back I fabricated a classic water inlet. It is connected to the tank with 50mm pipes that I cut to length and welded. In total there are 3 aluminum pieces that with silicone hoses create the complete inlet. Painted all black, mounted, tested, and it's leak-free. For the whole system I added an elephant's trumpet. It can be deployed through the rear door. In order to fill up the tank I need to close the water feed from the tank, open the water return valve, open the trumpet valve and put it into a water bucket. Doing so, I can run the water pump and direct water through the filter back to the tank, so I can easily fill the tank with filtered water so nothing is going to grow inside. The whole process of filling 65 liters takes around 16 minutes if I keep up filling the bucket. At the central console there is one more convenient button to run the factory pump at the engine compartment. It just runs water through a heat exchanger and I don't need to turn the ignition key to the second position and light up all the dashboard. The bottom profile of this tank is flush with the frame. It looks alright from the bottom. It does not drop too low. Believe it or not, but I'm not doing rock climbing with this G-Wagon, so this tank should be good for some time. Okay, so it is also working with a more traditional way, like with this water jerrycan, so I guess I can call this job done.